Hello, what's going on, Gracians? This is Sir Eman and welcome back to another episode of The Scientific Mind. Today we are going to talk about rocks and its main categories. But before we start our discussion about rocks, let's have our prayer first. Okay, so if you are ready to listen and learn knowledge about rocks and its main categories, let's begin now the discussion. Rocks and its main categories. So what is a rock? The word rock refers to a solid mass of the lithosphere. It is a naturally occurring solid mixture of one or more different minerals and other organic matter. Petrology is the science that is concerned with the study of rocks. A rock is a consolidated aggregate of various types of minerals or a consolidated aggregate of multiple individual pieces or grains of the same kind of the mineral. In other words, a rock is not one single uniform crystal. Although a few rock types are composed of many particles of a single mineral, most rocks consist of several different minerals. Each constituent mineral in a rock remains separate and it retains its own distinctive characteristics. The properties of the rock as a whole are a composite of those of its various mineral constituents. The number of rock-forming minerals that are common is limited, but they combine through a multitude of processes to produce an enormous variety of rock types. So what are the three classifications of rocks? First, we have igneous rocks, sedimentary rocks, and the last, metamorphic rocks. Igneous rocks. Igneous rocks are characterized by the interlocking texture of the grains, the presence of vesicular texture or holes in extrusive igneous rocks, may be dark colored and heavy, and it displays two grain size, one much larger than the other. When a molten rock material cools and solidifies, it becomes an igneous rock. Molten rock materials below the Earth's surface is called magma, whereas molten rock materials at the surface is known specifically as lava. Lava, therefore, is the only form of molten rock matter that we can see. Lava erupts from volcanoes or fissures in the crust at temperature as high as 1090 degrees Celsius or 2000 degrees Fahrenheit. The two main categories of igneous rocks are extrusive and intrusive igneous rocks. Igneous intrusive rocks. When a molten rock beneath the Earth's surface that is magma changes to a solid or when it freezes, it forms intrusive igneous rocks, also called as Plutonic rock after Pluto, a Roman god of underworld. Example of igneous intrusive rocks are granite and gabbro. Granite is a light-colored igneous rocks with grains large enough to be visible with the unaided eye. Granite is composed mainly of quartz and feldspar with minor amounts of mica, amphiboles, and other minerals. This mineral composition usually gives a granite a red, pink, gray, or white color with dark mineral grains visible throughout the rock, while gabbro is a coarse-grained, dark-colored, intrusive igneous rock. Next is igneous extrusive rocks. Are molten materials that solidifies on the Earth's surface. Extrusive igneous rocks is also called as volcanic rock. Example of igneous extrusive rocks are basalt, obsidian, and scoria. Basalt is a mafic silicate rock which is usually dark-colored, hard, fine-grained, and with high specific gravity. Obsidian that is formed from lava is also dark-colored but glassy, meaning it has no crystal. Scoria is a dark-colored igneous rock with abundant round bubble-like cavities known as vesicles. Sedimentary rocks. Sedimentary rocks form from material that has accumulated on the Earth's surface. The general term for the process of accumulation is deposition. The material consists of the products of weathering and erosion, and other materials available at the surface of the Earth, such as organic material. The process by which otherwise unconsolidated material becomes solidified into rocks is variously referred to as lithification, literally turning into rocks, diagenesis, or cementation. As their name implies, sedimentary rocks are derived from sediment. After the fragments accumulate, often in horizontal layers, pressure from the addition of more materials above compacts the sediment, expelling water and reducing pore space. Cementation occurs when silica, calcium carbonate, or iron oxide bonds the fragment together. The process of compaction and cementation transform or lithify sediments into solid, coherent layers of rock. The three main major types of sedimentary rocks are clastic, organic, and chemical sedimentary rocks. Clastic sedimentary rocks are derived from mechanical weathering. Weathering is a breakdown of rocks into smaller pieces. Clastic sedimentary rocks forms from fragments of pre-existing rocks, shells, or bones. Next, chemical sedimentary rocks form when dissolved material precipitate. Precipitation is the process of separating a solid substance from a liquid. When the amounts of dissolved minerals in ocean or lake water reach saturation, they begin to precipitate and build up as a deposit on the sea or lake bottom. When lithified, these sediments become chemical precipitate sedimentary rocks. Some fine-grained limestone rocks form in this manner from chemical precipitates such as calcium carbonate. The last one is the organic sedimentary rocks. It forms by the accumulated sedimentary debris caused by the organic processes. This may contain fossils of plants and animals trapped in the sediments as the rock was formed. Coal is created by the accumulation and compaction of partially decayed vegetation in acidic, swampy environments where water-saturated ground prevents oxidation and complete decay of the organic matter. The initial transformation of such organic material produces peat, which when subjected to deeper burial and further compaction is lithified to produce coal. Most of the world's greatest coal deposits originated between 290 and 354 million years ago during the Mississippian and subsequent Peninsulian periods of geologic time. Other organic sedimentary rocks developed from the remains of organisms in the lakes and seas. The remains of shellfish, corals, and microscopic drifting organisms called plankton sink to the bottom of such water bodies when they are compacted and cemented together. Rich in calcium carbonate, they form a type of limestone that typically contains fossil shell and coral fragments. Examples of sedimentary rocks. First, we have conglomerate. Conglomerate is a clastic sedimentary rock that contains large rounded clasts. Next is sandstone. Sandstone is a sedimentary rock composed of sand-sized grain of mineral, rocks, and organic material. Last, we have shale. Shale is a fine-grained sedimentary rock that forms from the compaction of silt and clay-sized mineral, particularly that we commonly called as mud. Sedimentary rocks are recognized by the grains cemented together, the presence of fossil, light-colored and lightweight, and it may display interlocking grains but is very lightweight. The last category of rocks is metamorphic rocks. Forms from the word meta, which means change, and morph, which means form. Metamorphic means change form. It is formed when a sedimentary or igneous rock is exposed to high pressure, high temperature both, deep below the Earth's surface. Metamorphism is the process that produces fundamental changes in the mineralogy. Protolith, the original rock, is prior to metamorphism. Enormous heat and pressure deep in Earth's crust can alter or metamorphose an existing rock into a new rock type that is completely different from the original by recrystallizing the minerals without creating molten rock matter. In recrystallization, mineral grains or their constituent atoms and molecules are compacted and rearranged into a new form that is more stable at a higher temperature and pressure. Compared to the original rocks, the resulting metamorphic rocks are typically harder and more compact, and have a reoriented crystalline structure and more resistant to weathering. There are two major categories of metamorphic rocks: the foliated metamorphic rocks and the non-foliated metamorphic rocks. Foliated metamorphic rocks have a layered or banded appearance that is produced by exposure to heat and directed pressure, while non-foliated metamorphic rocks do not have layered or banded appearance. Examples of foliated metamorphic rocks are gneiss, slate, and schist. Gneiss derives from conglomerate. It often contains feldspar or quartz. Slate is derived from shale. It is a fine-grained rock, while schist is made up of plate-shaped minerals grain that are large enough to see with the unaided eye. Examples of non-foliated metamorphic rocks are marble and quartzite. Marble derived from limestone. It is a hard crystalline rock and is considered as the most beautiful rock because of its shimmering luster. Quartzite is derived from sandstone. It is very hard and durable. Metamorphic rocks are recognized by the interlocking texture of large grain, foliation or layering, banded light and dark colors, the presence of a chink sound instead of a chunk sound when tapped. Next, uses of minerals. One may not realize it, but minerals are important in our lives. From morning until one's sleep, people interact with minerals. Minerals are components of materials we use, buildings we build, and assets we keep. That is how important minerals are in our life. Uses of minerals as home or personal. Aside from salt, other minerals compose of some the items and equipments found in our house. Feldspar is a component for ceramics, glassware, and pottery. It is also an ingredient in making soaps. Quartz is used for the production of glass and fiberglass usually used at home. Fluorite is also used in ceramics and pottery. It is commonly known as the component of toothpaste in the form of fluoride. Gold, silver, and platinum are made into pieces of jewelry and important articles at home. Electronics, infrastructure, and manufacturing use of minerals. Copper serves as an important material in electronics and wiring because of its conductive properties. Silver is utilized in electronics in the same way. Silica is mineral that contains silicon, a metalloid that has some properties of metal such as the ability to conduct electricity. Tungsten and molybdenum are used widely for the filament in incandescent bulbs because of their high melting points. Iron ores are used for stainless steel production. Other minerals that are important to electronics, infrastructure, and manufacturing are barium, chromite, cobalt, molybdenum, and nickel serve as alloys in the production of other metals. Bauxite is an ore where aluminum is derived. It is important to produce cement for construction. Copper and lead are also utilized widely in the construction field. Quartz in the form of sand is valuable in construction and manufacturing. Graphite, known in your pencil as lead, can also be used in manufacturing. Next, use of minerals in economics. Mining of minerals contribute to the gross domestic product or GDP of a country. Gold is used as a reserve and serves as a backup for currencies. The amount of reserve of gold correlates to inflation. If the central bank of a country buys gold, the country's currency is affected because of the fluctuation in the supply and demand of the currency. Use of minerals as precious materials. Some minerals are used as gemstone. Rubies and sapphire contains aluminum oxide. Emeralds are from the mineral beryl. Quartz is also considered as semi-precious mineral. Diamond, a form of carbon, is considered as the most precious mineral. It also the hardest mineral with a scale of 10 in the most. Though commonly used for jewelry, some uncut diamonds are placed as additive for metal cutters because of its hardness. In some cases, minerals are used in the medical field. Examples of these minerals are barium that is helpful additive to medicine in X-ray of the digestive system, and iron which is used to treat anemia. That ends our discussion for today. I hope that you learned something about rocks and its main categories. Again, this is Sir Eman of the Scientific Mind. See you on next episode.